Okay, now we have another example, example 5. We have x cubed plus 3x squared is greater than 4x. All right. First thing is, please, this is something that I need to mention because I know some of you you're going to make such mistake if I don't mention what I have to mention now. Now I know that x is common on the left and the right. Please don't make the mistake of dividing all two by x. All right, don't do that. When you're dealing with inequalities, please, x don't cancel. You don't do that. All right, you can't cancel x. What you need to do is to transpose. Take this guy to the other side. All right. You see what I have here? X cubed plus 3x minus 5 greater than 0. Factor out that x that is common, and then factor this quadratic expression. You end up with something like this. You see, now I have 3 critical values. If you made the mistake of dividing all through by x, you're going to lose this critical value 0. All right. You end up with just minus 4 and 1. And when you do that, you guys start emailing me, but say my answer is correct, do I get half of the mark or even a 0? Because you divided all through by x. So please don't divide all through by x. Transpose, take everything to one side, factor out anything that is common, and then solve from there. I'll just go ahead and explain using the easy method, which is method 2, number line. You see, I just write my critical values in ascending order. So minus 4, 0, and 1. And I test the sign in between. You see here we have our negative. Here if you test, you have positive. There you have negative, you have positive. Everyone knows where we're getting the signs, right? You just choose some numbers between those intervals and plug it in here. And then see if you get a positive or a negative sign. All right. Now, how do I read off my final answer? How do I read it off? I go back, I focus on the inequality here. The inequality has to be greater than 0. So it has to be positive. So it means that we'll be focusing on this region. You see there's positive. And this last region is also positive. All right. You can see that between minus 4 and 0, is positive, so I have x lies between minus 4 and 0. I use union, so this union here stands for or. All right, you see they're they're different regions. You can say intersection. Intersection is when you're dealing with one region combined or two regions that can be combined into one. In this case, you can combine these two regions because you see in between here, nothing exists. All right, it's not true. The inequality is not satisfied. So the two separate regions, you say is either this region or the other region. All right, be careful. The word intersection means there's something common on both sides. But in this case, there's nothing common. All right, so it means that we're going to use or. All right, union, 1 to infinity. Now, someone is going to ask me why open bracket and not close bracket. It goes back to the inequality. You see, I say strictly greater than 0. I didn't say greater than or equal to. Because it's strictly greater than 0, if you try and plug in any of this value, for example, if I put minus 4 in there, I get 0. Is 0 greater than 0? The answer is no. That's why you see here is close. All right, it's close here. And if you also test for, 0, 0 will not be greater than 0. If you put in 1, if you put 1 minus 1, it will just be 0. And again, 0 cannot be greater than 0. You see, everywhere it will just be open bracket. And once you give me this, you have your full marks. So please, you follow all the steps. Show me the number line. Please don't skip number line. Most of you marks are allocated for number line. All right. You can just move from here straight to this final answer. Show me number line or show me your table method if you prefer to use your table method. Show me something. All right. If everyone is happy, let's move on to absolute values. All right. Now, what are absolute values? By definition, we say the absolute value of a number A is denoted by, you see, I have these two signs, we call them the pipe signs. All right. So this absolute value is just a distance from that number to the origin. So what that simply means is, let's say that this is 0. You have some number, the A. Let's assume you have another number, the B. Now, the absolute value of A is just this distance from A all the way to the origin. So this distance here will be the absolute value of A. Now, if I ask you for the absolute value of B, which is on this other side, again, it's still this distance from that number all the way to the origin. All right. So that is a definition of absolute value. Now, let's look at this. Guys, this is very important. If absolute value of A is exactly equals to A, then it means that A is actually greater than or equals to 0. All right. And if absolute value of A now becomes negative A, it means that your A you're dealing with was actually negative. So this A that goes in here was negative. All right. And what is absolute value is the same as just saying square root of a number squared. For example, let's look at this. What is the absolute value of 3? It's 3 because 3 is a positive number. What is the absolute value of minus 3? It's 3, but I'll explain how you also got 3. We said that if it's negative, you use minus the original value. So it becomes minus 3, which is why you still have 3. So absolute value will always be positive. All right. Now, what's the absolute value of root 2 minus 1? Remember that root 2, you just have something like 1.14. All right. And if you do that, this subtraction here means it's going to be positive. So 1.14 minus 1 is some positive number. Hence, it stays exactly the same. All right. Now, this one, 3 minus pi, pi is 3.41. It therefore means that you're going to have some negative value in here. 3 minus 3.1 or 3.41 will give you a negative value. Hence, I need to say minus everything that is inside here. And if you negate that, notice you just have pi minus 3. Please watch out for tricks like this in your quiz 1. All right. Let's see. I think someone wrote something in the comment area. Someone can hear anything. Just check your device and make sure that you are not muted or something. So check that your volume is up. All right, let's move to example 6. Example 6 just want us to write. They say we should write this without using the absolute value symbol. Now, how do we get rid of this absolute value symbol? We know that if I give you absolute value of some expression 3x minus 2, you agree that it can either stay the same or it can be minus, all right? Now, when does it stay the same? It stays the same if that expression is positive, means it's strictly greater than or equal to 0. And it becomes minus the whole expression if the expression is actually negative, right? And if you simplify that, you get 3x minus 2 if x is greater than or equal to 2 over 3. So I just simply make x the subject there. So I solve the inequality. And similarly, if you negate this piece here, you end up with 2 minus 3x. And that happens if x now is, so if you solve for x down here, notice that x will just be less than 2 over 3. You see, you've gotten rid of the absolute value because now you have this new expression here. All right. Let's look at some properties of absolute values. Now, the first property, before I go to the properties, they say suppose A and B are real numbers and n is an integer. All right. So A and B have to be real numbers and n has to be an integer. We say that the absolute value of the product of A and B is just the same as the product of the absolute value of A and the absolute value of B. Easy as that. The absolute value of A over B is the same as absolute value of A divided by absolute value of B. The condition is that the bottom cannot be equal to 0 because you can't divide by 0. And if I say absolute value of A to the power n, remember here n is an integer, we can just say the absolute value of A all raised to the power n. All right, so I can take the power outside of the absolute value sign. All right. This is, you see that I even put a little take note. It means that you need to remember these 3 rules here. They're so important. All right. The first rule, and this only applies when A is greater than 0. So we say suppose A is positive, then if absolute value of x is equals to A, then we just say x is equals to plus or minus A. All right. Now, if I say absolute value of x is less than A, it means x lies between A and minus A. And if the absolute value of x is greater than A, therefore you have that x is either greater than A or x is less than minus A. Guys, There's three stuff here you need to remember them. All right. Because you will be tested on this kind of stuff. For example, they say solve for absolute value 2x minus 5 equals to 3. Like I said, to get rid of the absolute value sign, you introduce a plus or minus on the right hand side. All right. And it just becomes 2x minus 5 is equals to 3, or 2x minus 5 equals to minus 3. You see, x is just equals to 4, x is equals to 1. All right. Okay, let me just quickly go back. Someone say, when there's a negative sign, we have an open interval. Okay, I'm not sure exactly what question they're referring to. So open interval is not necessarily have to do with the negative or positive sign. So if I say, for example, x is less than a, you see the fact that I say less than, or I can still say greater than, this stands for open interval automatically, all right? And if I use something like this, x is less than or equal to some number, all right? Therefore, this now signifies closed interval, all right? So similarly, we can say x is maybe greater than or equals to some number c. All right, those are closed interval. So your open and closed interval has nothing to do with a negative sign or a positive sign. All right. So including the interval, when you solve an inequality, it just depends on what that inequality sign is. All right. And if when you substitute that x value, it satisfies the inequality or not. All right. I hope that helps. If you still have any doubt, you can email me, and then I will probably solve another example and explain even further. Now let's look at example 8 and 9. For example 8, we have solve for absolute value x minus 5 less than 2. Remember the rules. The rule says that if you have absolute value less than a number, it means that that whole expression lies between 2 and minus 2. All right. And you can, if you solve this, remember you can just add 5 all 2. So minus 2 plus 5, you see there's 3. Then if you add 5 in the middle, the minus 5 disappears. And if you add 5 here, you just have 7. There you go. And like I said, I'll prefer you to give me in this notation. So it just means x lies between 3 and 7, open interval. There we go. The guy that was asking me about the open interval, you see it's open interval because we're dealing with stuff like this. We say it's less than, x is less than 7, automatically means open interval at 7. And x is greater than 3, you see, it means that you also have open interval. The fact that I do something like this, let's say I go to the equation, I change it, and I do something like this, it becomes less than or equal to. Similarly, here you also change it to less or equals to. There it will also be less or equals to, less or equals to, less or equals to. And your final answer, everything here changed to close interval now. All right. I hope that makes sense now. All right. And the last one where most of you get confused, I don't know why, for my many years lecturing, I think this is the example that, not the specific example, but when you have to solve for greater than or equals to, most of you do make a mistake. I don't know why, but let's see how you're supposed to solve this. So to solve this, you apply the third rule that says that absolute value greater than, you have two p's. The first piece is the expression has to be greater than or equals to 4. We say or the same expression needs to be less than or equals to minus 4. Very important. So it has to be greater than 4, or it has to be less than minus 4. All right. You solve these two sides separately. So solve for this separately, solve this, but the order stands for what? It stands for union. You see, that's why I have this expression here. All right. And the guy with the interval, the problem with intervals, again, I'll explain why we have closed and open. When you have infinity or minus infinity, there's only one possibility. It can only be open interval. You see here, infinity or minus infinity, automatically it has to be open interval. Why? Closed interval means that you including that number, but infinity is not a number. You can't include infinity. That's why it has to be open. Now, let's look at 2 over 3. We say x needs to be greater than or equal to, means we including 2 over 3. That's the reason why you have closed interval there. X needs to be less than or equal to minus 2. Again, you including minus 2. That's why you have, again, a closed interval there. All right. So please just give me in set notation. I know some of you love writing this set builder notation, but preferably just give me in set notation. Let's see if there's any other question. Okay, just send it to my email address. I'll mention it before the end of the session. Or if you check the email that you receive, I sent it using my email address. So if you receive an email from me, it means you have my email address. Triangular inequality. This one, you can just ignore this piece. It's just for self-study, but I'll go over it quickly. I'm not going to test you on this. Now, it states that, okay, guys, can you mute? I think someone has unmuted themselves. So for triangle inequality, says that absolute value of A plus B is less than or equals to absolute value of A plus absolute value of B. And if you see there, there's a quick proof. A lies between absolute value of A and minus absolute value of A. This is true because absolute value of A can either be equals to A or it can be equals to minus A. All right, you only have two possibilities. That is what makes this statement to be true. Similarly, it's also true for B. So absolute value of B can either be B or it can be minus B. So we say that B lies strictly between absolute value of B and minus absolute value of B. Now, if you add everything up, so if you add these two together, you get this. If you add A plus B, and if you add absolute value of A, absolute value of B, you get something like this. And if you remember well, when you have an expression that lies between two terms, with one being positive and negative, it's equivalent to saying absolute value less than or equals to. All right. So for example, if I just say X lies between, let's say A and minus A, all right, I can translate this directly to absolute value of X. So I can translate this to absolute value of X to be less than A. All right. So it's more or less the same idea. So this whole expression can be translated in the same way. We can just say absolute value of this middle term, which is A plus B, is we look at this sign now, we're dealing with less than or equals to, all right? So it becomes less than or equals to what happens there, which is just absolute value of A plus absolute value of B. So that's the end of the proof, all right? Example 10, again, like I said, is not for the sake of assessment, it's just for you to understand, but I'll just go over it again, just for those that need to understand this piece. So I give you these two inequalities. Say absolute value X minus 4 is less than 0.2. Absolute value of Y minus 7 is less than 0.2. And I say use triangle inequality to estimate this. Now the idea is to try and rewrite this as two absolute values. So X plus Y minus 11, I can write it as X minus 4 plus Y minus 7. Remember, if you simplify this whole thing here, you just end up getting what you have there. And why do I think of writing it as these two expressions? Because we know these two already. We know what absolute value X minus 4 is and what absolute value Y minus 7 is. Now, if you apply the rule of triangle inequality, it says that absolute value of A plus B is less than or equals to the absolute value of A plus the absolute value of B. There we go. So from this step to this step, I'm just applying the triangle inequality rule. But now we were told that this is, so the first one there is less than 0.1. You see there I put a less than, and I put 0.1 where it is. And there's a plus, because there's a plus sign there. We were also told that this inequality is less than 0.2. So you see again, I just put 0.2 there. Therefore, this whole expression is less than 0.3. Therefore, in conclusion, we say that absolute value is less than 0.3. All right. And as usual, homework problems for you. Go and look at this homework problems. You can see I was nice enough. I gave you guys the answers. Please make sure you can do these problems and get to these answers. All right. Especially for stuff like this first one. All right. And just to give you a quick hint for the first one, this first one is very important. In fact, everything is important. That's why I said take note. The first one is testing you on the idea that you can't just cross multiply by x. Guys, in inequality, you don't cross multiply both sides by a variable online unless what you multiply in both sides is actually positive. All right. For example, if I multiply both sides of this inequality by, let's say, x squared, all right, then the inequality sign will not change. But I can't make the mistake of multiplying both sides of this inequality by x. You can know that's the first thing that will come to mind when you guys try to solve this. You just try and multiply both sides by x to get rid of this, and then no, you do that, you will never get to this answer. All right. Please make sure that you can solve, especially this first one, because in the past years, many people struggle with this kind of problems. This one is split it into two using and because an intersection. Then this one, we've already done an example that looks like this. This one obviously is an equal to, means you get rid of this absolute value, then you introduce a plus or minus. Then you have two statements. Either this statement is equals to 3 or is equals to minus 3, and then you're good to go. All right. It looks like we will not be able to do Appendix D today, but it's fine. We'll do it in our next class. This is the end of our session. If you have any question, you can quickly put them down so that I can answer them now. Or if not, send me an email and I'll gladly respond to your email. If you have no question and you're happy, you're more than welcome to leave the session. I will see you again on Tuesday, same time.